All right. Two systems, a simple pendulum and a mass hanging on an ideal spring, both have a period of 1 second when set into small oscillatory motion on Earth. They are then set into a small oscillatory motion on planet X, which has the same diameter on Earth but twice the mass. Which of the following statements is true about the periods of the two objects on planet X compared to? All about formulas, guys. What is the formula for the spring mass system? 2 pi root m over k. No involvement of g, correct? And what is the formula for the pendulum thing? That is 2 pi root L over G. There is a G. So that is for sure that the spring mass system doesn't really, nothing happens, because when you take it to another planet, obviously the gravity changes and the mass and K will not change because these are physical properties of the object. So these are not going to change. So the time period of the spring system is not going to change. So this has to be option D, right? Well, the options are pretty easy, I think, because this is the only option where the period of the mass of the spring is same. Okay, all right. You can, because this can also be the answer. Got it. Okay, so why D? Which one is it, B or D? Let's find out the spring thing now. Um, what is the formula for the graph? In fact, we don't even. Okay, yeah, we need to know. What is the formula for the gravity? Because they are saying that it has the same diameter but twice the mass. So the gravity formula on any planet is given by g times mass of planet over radius of that, or r square, where r is the distance from the center, right? Now they are saying that it is the same diameter, so the same radius, so this doesn't change, but the mass is double. This is doubled. So obviously when you double the numerator, this g will increase, right, as compared to the Earth. So if g is going to increase, definitely this is going to change. So g is going to increase, so this is going to decrease, so the time period decreases. So it should be shorter. Anyway, the answer option D makes also makes sense, because the moment we see that change of the diameter or mass or anything changes g, and change of g, length is not changing, so change of g will definitely change the period. So it cannot be B, right? How can they be same? It has to change. But yeah, now we also know that why it becomes shorter, why it's not longer, right? So yeah, that was the answer to this question.